we are given that such a system is rotating with angular speed equal to omega naught. If you now displace the block radially, then the motion of the block will be like this. If we work in a reference frame, rotating with the system, then motion of the block will be in SHM. In this frame, let us consider the forces acting on the block when it is displaced by a distance x. First of all, we have the pseudo force equal to m omega naught square x, radially outwards. Also, as the springs are elongated and compressed by the amount x, therefore, the force due to the springs will be equal to k1x and k2x in the same direction. Therefore, the net restoring force will be equal to this term. Writing net force equal to mass into acceleration, we can say that omega will be equal to this term, and time period of oscillation will be equal to 2 pi by omega. Please note that here you should not confuse between omega and omega naught. Omega is the angular frequency of oscillation, and omega naught is the angular speed of rotation of the system. Now, from this equation, we can see that this term will be equal to 0 for omega naught equal to this term. That is, the time period will be infinite for this value. This means that for this value of omega naught, the centrifugal force on the block will just balance the force due to the springs, and there will be no restoring force on the block, and thus, no oscillations. Also, if omega naught is greater than this value, then the centrifugal force will exceed the force due to the springs, and the block will have a radially outward acceleration. Therefore, for the block to have an SHM, omega naught should be strictly less than this value.